Hey everyone, it's Tuesday and it's 3 o'clock. That means it's Tech Tuesday, and today's topic is going to be coherent optics. CableLabs has released a specification for that, and that means 100 gigabits per second on fiber with one wavelength. Be right back and we'll talk about it. Thanks for joining me. Rick Usey here with Tech Tuesday. So this was an announcement that CableLabs made in a recent blog post. I was going to go through this blog post, talk about a couple of things, maybe explain some things, and then also look at the specification, just kind of go through a few parts of that. So again, this is CableLabs. CableLabs is the organization that has been mostly associated with cable providers because they are the folks that wrote the DOCSIS standards that started out DOCSIS 1, 2, 3, 3.1. DOCSIS 4.0 now is being in the process of being deployed by various operators, the different pieces of that. So that is who CableLabs is. And as cable has progressed, as the technology has progressed, starting out with all coax networks and then into hybrid fiber coax, where fiber has been more and more a portion of the network. And so CableLabs has been working on fiber standards. So this standard for coherent optics is something that can be used in an HFC or hybrid fiber coax network, as well as just fiber to the home, fiber to MDUs for backhaul, front haul, those kinds of things. So we'll talk about a lot of that. So CableLabs definitely shifting into the fiber realm here even further, again, as they're trying to increase the speeds and the performance that you can get on an HFC network, a cable network, as well as integrating in with other kinds of connections such as fiber. So, and doing those things all at the same time. So let's take a look at this. So you see here, get ready for 100G CPON. Architecture specification issued. I find it interesting that it's CPON because we're talking about coherent PON, so C for coherent, I guess. But this is also 100 gigabits per second, so kind of like XGS PON, the X being Roman numeral 10 gigabits per second. Here we've got CPON, and it's 100 megabits per second. So I'm not sure if there was any thought in that or just happened a happy coincidence. So the advancements of coherent passive optical networks, or CPON, will lead to a robust and noticeable boost to the customer experience in businesses and the home. The benefits include providing faster downloads, less buffering, and increased capacity for many consumer devices using applications simultaneously. Since passive optical network, or PON technology, was first deployed in fiber to the home networks over 30 years ago, it's evolved from 622 megabits per second to the 10 gig capacity, again, XGS PON, being deployed by network operators today. As consumer appetite for bandwidth continues to grow, CPON will prove a scalable and extensible technology for fiber networks for the next 30 years. So they're looking further into the future now with this technology. Moving the industry closer to the future of PON technology. So CableLabs has, scrolling the wrong thing there we go. CableLabs has now issued the architecture specification for CPON, 100 gig per second, single wavelength PON. That's kind of a key thing, single wavelength. So that is a link right there. I linked to this article, this blog post, in the description of the video, so you can check this out, and also click there to get to the specification that I'm going to show you, where you can download it as well. With increased capacity per wavelength, extended reach, and higher port density, CPON represents a monumental technological advancement for next-gen broadband access over fiber optic networks. This advancement in speed is a tenet of the 10G platform, with the specification ultimately bringing faster experience to consumers, businesses, and network operators. So 10G is something that was, the 10G platform initiative is something that CableLabs came out with several years ago. I've talked about that several years ago. 10G, the G meaning not generation, but gigabits per second. So originally the thought was 10G would be the next step for cable networks on being able to do 10G symmetrical kinds of service. And it was part of it was a reaction to 5G, and that was actually generation, not gigabits per second. That was 5G, obviously the mobile and then also fixed wireless standards for 5G was 5th generation wireless. So there was a lot of hype about that and how that would be killing wired services, because it would be wireless and you could get really fast speeds over a gigabit per second over wireless, but that's only applicable if you live in an area where you can get small cell millimeter wave service. So you have to have highly dense areas where you have lots of small cells, and you can do millimeter wave because you need line of sight, because those signals are very easily attenuated by even moisture in the air. So the 5G thing never really amounted to killing wired service. It is a very good service, especially with mid-band spectrum, where you can go further and have better penetration through various things. But it's great for that. But mid-band spectrum isn't nearly as fast as you can get with millimeter wave spectrum, and it's not as fast as obviously you can get through some of these wired technologies that we're seeing, especially fiber and DOCSIS 4.0, the latest standards that are coming out for cable. So again, part of the 10G initiative, and 10G and DOCSIS 4.0 are kind of almost the same thing, because a lot of things that they're doing for DOCSIS 4.0 are part of the 10G in order to be able to do the higher speeds. DOCSIS 4.0 is kind of a compilation of some existing technologies and some new technologies to boost the performance of cable networks. Increased capacity, extended reach, those are parts of the benefits here. So current established PON standards are approaching limits in terms of capacity and network reach. By contrast, 100 gig CPON provides the increased network capacity needed for emerging applications in high-resolution interactive video, augmented reality, virtual reality, mixed reality, the metaverse, and smart cities and pervasive communications. This ample capacity makes it possible to support residential broadband customers and to aggregate optical links to small businesses, enterprises, and wireless access points. CPON also introduces coherent detection, so a lot of this has to do with the coherence part of it, to broadband access networks, enabling superior receiver sensitivity that allows for an extended optical power budget and higher spectral efficiency. Coherent detection enables 100 gig of capacity on a single wavelength, and that's key, as well as extended reach of the network or a higher split ratio, so you have a balance of how far you want to go versus how many splits you want to have, for more efficient sharing of network resources. So the single wavelength thing is important because right now, for example, in a cable plant or in other scenarios, you have, as far as I understand it, you've got two wavelengths you've got to use, because if you want one for upstream and one for downstream. Well, with coherent PON, with coherent optical networks, you only need one wavelength, and you can send the information in both directions at the same time on that single wavelength. And it uses these detectors to be able to kind of navigate the light around them, each other as they're going in different directions. So that's kind of key that, for example, in a cable plant, normally you'd have two lasers, on each side doing upstream and downstream. Now you only need one. So you can decrease the number of lasers, the cost, the chance of something failing, those kinds of things. And that goes also for fiber networks, obviously, however you're using this technology. In addition to increasing capacity, and by the way, I did a broadcast on coherent optics with Marty Kukul, one of our network engineers and solution architects, back a couple of years ago. So I linked to that as well in the description if you want to check that out and learn a little bit more about coherent optics. In addition to increasing capacity, 100G CPON extends the reach of PON over fiber networks up to 80 kilometers. Current PON technologies have trouble reaching 25 kilometers, and that's what they're talking about there with, let's say, XGS PON. You're only going to get up to, say, 25 kilometers. Limiting deployments to urban centers and suburban areas. Now, I believe CPON, or coherent technology, not CPON necessarily, but coherent optics can go much, much further. It's actually used for very long haul kinds of applications, but it's also very expensive that way. So what this is doing is reducing the distance that you're going, and then you can reduce the costs of some of these parts and pieces that have to be in here to do coherent technology. Limiting deployments again to urban centers and suburban areas. Implementing these technologies at the edges of suburban areas and into rural areas commonly requires backhaul using active optical links or facilities such as fiber huts. With a fully passive optical link up to 80 kilometers, and what's that, 50 miles, I think, 100G CPON solves these problems and enables cost-effective deployment of fiber to the home in unserved areas. OLT ports support more users, so you can do higher splits at some of these distances. So OLT ports supporting higher split ratios with CPON provide more efficient bandwidth sharing, resulting in cost savings for space, power, and cooling at the hub. Current PON technologies are commonly deployed in a split ratio of 32:1 or 64:1. The split ratio means an OLT port shares network capacity, or the 10 gigs, among 32 or 64 end users. CPON offers a split ratio of up to 512:1. providing 100 gig to support up to 512 end users on a single OLT port while maintaining a typical reach of 25 kilometers. So that would be your high-end split where you can get up to 25 kilometers doing a 512 to 1 split. If you want to get to this 80 kilometers, it's a 16 to 1 split. So you have, you can do, again, it's a trade-off. You can do fewer splits to extend your distance. The CPON specification working group consists of 17 optical vendors, 14 network operators, CableLabs, and SCTE. So again, you can click in here to get to the specification. And I pulled that up, and I will just talk through a couple of things in here, again, to try to explain a few things. So again, this is the coherent passive optical networks, 100 gig, single wavelength PON. You can see where they are in this. So this was May 3rd that it was released, and the status is issued. So it was a work in progress, then it was a draft, now it's issued, and then finally it'll be closed. They still need to do technical requirements for this. So this is probably 4 to 5 years away as more vendors are jumping on and they're going to do the technical requirements, and you have to start doing those pieces of it. So this is not coming out tomorrow, but with this portion of the spec done now, they can get to work on the next section of that would be, again, I think those technical requirements. Again, this is issued a public document that has undergone rigorous member vendor review, supports cross-vendor interoperability, and is suitable for certification, qualification, testing. Issued specifications are subject to the engineering change process. So again, that's the next step. And CableLabs is really good about this. So again, the DOCSIS standard has been something that's one of the reasons that cable's been so successful over the years and been able to continually evolve and increase capabilities while keeping itself backward compatible in so many areas, because you've got these rigorous standards. When equipment comes out, you know that if it supports the DOCSIS standard and everything that's in there, that then equipment manufacturers and folks like us that create diagnostics applications, for example, for DOCSIS, find it much easier to be able to develop that or create or manufacture that equipment and develop applications around that, because we have the set standard that we know everybody is supposed to meet. That doesn't mean they always meet everything, but in order to be DOCSIS compliant, you need to meet, I think, probably everything, if not most of all of those specifications. So it makes it easier on folks like us. Now, we also provide fiber diagnostics, but that's a lot harder because we have to, rather than ensuring that we meet DOCSIS standards, we have to then look at each piece of equipment and how they're implementing stuff. And they may implement it differently, and they may have different things in different areas that we have to pull from. And then they may change something later, which can cause an issue. So we have to constantly keep up with that. Whereas with DOCSIS, it's much easier. So CableLabs, I think, getting involved in this and doing this is going to be great for the industry, because this will be a standard that, again, you see it's already undergone a rigorous member and vendor review, and that will be the case moving forward. And then there'll be testing and all those kinds of things. So it'll be a standard that everyone can be on board with. You see they've got their table of contents here, various figures, tables, etc. So just a couple of things in here, again, I wanted to talk through. So the introduction and purpose, the spec is part of the coherent or the CPON family of specifications developed by CableLabs. These specs enable the development of interoperable transceivers using coherent optical technology over point to multi-point links, basically. The specification serves as a guide for identifying use cases, which we'll talk through some of those use cases, identifying the optical distribution network scenarios, which is in here, and then identifying operational needs in order to address use cases in ODN scenarios. The resulting CPON system features symmetric line rates of at least 100 gig over a single wavelength, again, one wavelength. More significantly, it features an optical power budget up to 35 dB, which enables long link distance up to 80 kilometers with a 1:16 split, or high split up to 1:512 with a 20 kilometer distance. That's about 12, almost 13 miles, I think. It will also support coexistence with any existing fiber-based technology. That's important. So again, we don't want to roll out something that suddenly you got to throw everything else out. So this will coexist with other fiber systems, such as legacy PON systems or wave division multiplexing point-to-point links, and have the ability to stack multiple CPON wavelength on a single fiber by using WDM. So they can you can have CPON networks coexisting with each other in addition to these other legacy kinds of things. Figure 1 shows an example of multiple CPON wavelengths on a single fiber link to support mixed use cases or applications simultaneously. So you're looking at we'll see this figure again here in a minute, but you're seeing you've got OLTs back here in like a central office, then you've got You've got, what do we got here? We've got ONUs. So ONUs would be, this is basically your network access equipment. This would be either your end user equipment or, if you're serving a building, that kind of thing. Your CPE, ONUs, you'll also hear referred to as an ONT. So you've got your ONUs in here. Then we've got remote OLTs. So we've got OLTs here in the central office. We also could be connecting to a remote OLT with remote ONUs out here. And then we've got on the cable side, we could have remote PHY devices, remote MAC-PHY devices in a distributed access architecture network. So this would be a cable kind of, you see here coax, a cable kind of use case. And then you've got over here some ONUs, and you've got a fixed wireless kind of use case or wireless use case, one of those. So background is the PON evolves towards a data rate of 100 gig or higher. PON technologies based on intensity modulation direct detection, or IM-DD, have been pushed to their limit to accommodate the fast-growing demands. In contrast, coherent optical technology is a very promising solution for 100 gig single wavelength PON because of its superior performance and vast potential. Coherent optics technology is common in submarines. So again, this is talking about the long haul situation. So common in submarine cable, long haul, and metro networks, but it has not yet been applied to access networks because of the relatively high cost of the technology for those applications. However, the access network differs from the other types of networks in the following ways, and it talks about you're not going as far, so you're typically less than 80 kilometers, fewer transmission impairments because of the shorter distances, use of fixed wavelength optical passives, and these things will help in keeping the cost down. So again, with these differences, capabilities, performance, and features, transceivers can be relaxed in certain areas, and you're going to keep the cost down. This allows for low-cost designs and the use of low-cost components. Let's see what else we got in here. Oh, we've got a nice terms and definitions if you want to look through that. If you ever wondered what some of these things mean, this is a good place to look. And they show you what the different things are in the diagrams that they're using. Again, you got your OLTs, ONTs, got your base stations on a wireless network. You got base stations, then you got your radio units for your backhaul and your front haul, which we'll look at here in a minute. There we go. So different things. Then you got abbreviations. So it's always good to see what these abbreviations are here. A bunch of those that you can look through. What else we got? Oh, here we go. Coherent optical technologies have completely transformed optical transmission systems and enabled a widespread upgrade and new deployment of dense wavelength division multiplexing networks to speeds of up to 100 gigs, 200 gigs, and 400 gigs per wavelength. Over the past decade, coherent optics has moved beyond its long-haul application origins and is now used in metro networks. So we're squeezing down where we're using this, and now it's going to be useful for fiber to the home, those kinds of things, or again, in a cable network for the fiber runs on that. So a couple of different things in here you can look at. I did want to go through the specific use cases. For example, again, residential fiber to the unit, I guess, MDU, multi-dwelling unit, fiber to the unit. CPON supports the use case of fiber to the unit and multi-dwelling units where each suite of in the building is a separate, distinct customer, and each customer is served by a single fiber drop in an ONU. Again, that ONU or ONT, that would be kind of your CPE, usually, on the wall, and then it hooks up to a router generally, and from there you get your service. Could be wireless service in the apartment or whatever. The CPON OLT is located at the hub. The splitter is located at the building complex, and multiple ONUs are fed through drops connected via riser cabling in the building with a single splitting point. Another option is to use one splitter per building floor with the entry splitter located in the basement of the building. So they're looking at a couple of scenarios like that here. So here you've got your OL2 back in the hub, and you've got your CPON. Then you've got your ONU. It could be going to one place in a building and then splitting off there. You could have splitting off going to the different apartments, going through the risers that way. Residential fiber to the home, or single family units in this case. So in brownfield deployments, with existing TM-DD PON, a CPON network could be, and again, that is, I've got that acronym somewhere else here. We'll look at it again. We just talked about it, but with existing IM-DD PON, a CPON network could be overlaid using coexistence modules, again, allowing these modules to have everything coexist in the one network, allowing the operator to gracefully migrate certain customers to increase revenue opportunities or lower congestion for other customers on the ODN. In other words, you don't need to do this all at once. It's not like you need to say, okay, we're going to do coherent optics now. You can do it in pieces, and you can have this coexistence between your existing technology and the new CPON technology. Talks about here residential. Again, this is residential. So you're looking at the OLT and your CPON, and then you've got your splitter here, and you've just got ONUs at each individual home. So that's kind of your standard fiber to the home kind of thing, but using the coherent technology. Aggregation connectivity. GPON can also support backhaul connectivity of remote devices on an operator's network. You can have remote OLTs, as we saw in that diagram. GPON or CPON can provide connectivity and backhaul of remote OLT traffic. And that's what you're looking at here. You've got your OLT, and then you've got your remote OLTs out in the field in nodes. And then you've got your remote ONUs out there where you're connecting to the end user person or device. Distributed CCAP, that would be your converged cable access platform. This is cable operators, and CCAP is it's basically video and data on one piece of equipment or on one network versus let's say just data or just your video. So that's what a CCAP is. So CPON can provide connectivity and backhaul distributed converged cable access platforms, or CCAP architecture traffic collected from remote PHY devices, or RPDs, and remote MAC-PHY devices, RMDs. I talked about that recently, where what cable operators are doing to improve the reliability of their network, to improve the performance, to reduce the maintenance, is they're deploying more distributed access architecture, which is this remote PHY or remote MAC-PHY. Remote PHY being where you still have a CMTS or CCAP in the head end, and then you've got remote PHY devices. So you go digital fiber instead of analog fiber out to these RPDs, or these remote PHY devices, where you've got your physical coax connections, and then it goes coax from there to the end user, usually with some actives, and obviously actives and passives, or at least certainly passives between there. So you could have one or more amplifiers, and then you get to the end user customer, and it's coax basically at that point. So that's your hybrid fiber coax. So you've got, in this case, digital fiber going out to the RPDs, then you've got coax going out to the end user customers. So you're looking at that here, where you've got the OLT. OLT, wait a minute, that's something else here. OLT, CPON. Yeah, okay, I'm not sure what they're showing here. So we got an OLT in the head end or in the hub. Then we got RMDs embedded with CPON ONUs, and we've got our coax. So yeah, I guess that is. So they're basically saying, I guess that would be the case. So when you're doing this digital fiber, you're going to need this aspect of it. But I was thinking, in the head end, you've actually got, on this scenario, you've got a CMTS or a CCAP, still what you're doing there to deliver this service. Then you've got, again, your RMDs or RPDs. An RMD would be a remote MAC-PHY device. So I was talking about the remote PHY device. That's just taking your physical connection out to the edge, where you're going to connect up your coax. The remote MAC-PHY device, or an RMD, is where really that is where your CMTS is out in the field. And basically it's a mini CMTS, if you look at it that way. So it's a CMTS out there that's going to support fewer customers that you've got out on the edge, as opposed to a big piece of iron that you've got in your head end that you're serving everybody. And in general, you have like servers that are running like routers and what not that you need. So you're doing those kinds of things. That layer of things are still going on in the head end, but the MAC layer and your physical connections are out at the edge, closer to the customer. So again, you're doing the digital fiber out into the field, out to the edge of the customer. Then you've got your RMDs and your RPDs. And then out here, you see they're showing an example of some small cells out here. Would be for, let's say, 5G service. You've got, again, coax feeding all of this. You've got your residential cable modem customers. You've got some, looks like wireless base stations and businesses, those kinds of things. Then we've got mobile Xhaul. Xhaul would mean either backhaul or front haul. Figure 10 shows an example of mobile backhauling using CPON to provide base station connectivity and carry backhaul traffic. So this would be your backhaul use. So again, these are base stations. So these are not what would be connecting, these are not your radio units. So this is aggregating different wireless signals at base stations, and then those are being backhauled back to where your IP network is back here, and your other kind of equipment that would go in the network. Figure 11 shows an example of CPON supporting front haul connectivity. That's the next one. In a 5G radio access network, or RAN, the CPON system is applied in the front haul of the RAN to support multiple remote sites with up to 100 gig capacity. So this is your front haul. So here are where you've got your radio units that, let's say, fixed wireless or mobile subscribers would be connecting to. They're connecting here, and this is using your coherent fiber optics. There's your splitter coming back here to, let's maybe say a baseband unit. So again, this is your front haul right here, your fiber that's doing the front haul. Then you've got this section, which is kind of like one of these, I believe. And then these are being aggregated here into the IP network back here. So you've got, this is your backhaul. So you've got your front haul connecting to your backhaul, basically. Mixed use cases. So we kind of looked at this picture already. So we talked about the mixed use cases of different things here. Again, we've got, again, small cell. We've got a home connected to coax. We've got some remote fiber ONUs out here. We've got fixed wireless, let's say, out here, or this could be a mobile, just mobile as opposed to fixed wireless, those kinds of things. They've got additional use cases in here. Again, Wi-Fi backhaul would be very similar to what we were looking at on the mobile backhaul. Edge computing, fixed wireless backhaul, very similar, just on a broader scale using fixed wireless spectrum. Data center connectivity, passive optical local area networks, and IoT-based smart cities. So lots of small IoT devices communicating. So different things that can be done with this technology. There's stuff on ODN scenarios in here. I'll skip through. You can read through that. Fiber characteristics, distance and split ratio. I did want to, again, cover the different splits here. So they showed, we already talked about this. So we've got, if you're going to do a 1 to 512 split, then you can only go to 20 kilometers. And again, I think that's a little over 12 miles. You can do 50 kilometers if you do to 1 to 64, or you can do 80 kilometers. Again, I think that's about 50 miles at a 1 to 16 split. So that's what you're looking at there. System capacity, again, 100 gig both directions on one wavelength. So that's the thing there. And then it talks about coexistence here. Again, that refers to the ability for two or more different optical systems or generations to operate simultaneously on a common ODN. This helps minimize infrastructure cost, enable a smooth and non-disruptive migration towards CPON deployments. So again, reducing your costs, you don't have to rip stuff out, and you don't have to do it all at once. You can do this in pieces as you expand your network. And that's kind of what people are doing. Again, it's nice not to have to, with DOCSIS, it's nice to have things backward compatible. And we know with XGS PON, people are putting in XGS PON cards right now, even if they're not necessarily rolling out XGS PON, because the prices on those have come down to where you can put in an XGS PON and it still can operate on the old GPON cards, gigabit per second GPON cards versus 25 gigabits per second XGS PON cards. You can put them in the OLTs, and even though you're not using them, later when you do roll that out, you'll have that. So again, it's nice to be able to save costs and be able to, just with fiber, give somebody XGS PON in certain areas, and where you don't need to do it in other areas, you don't have to do that. Same thing here. You can give people the coherent PON in certain areas and keep the older version, the legacy PON, in the other places. And you see that here. They're showing that legacy PON, CPON, OLTs. You got legacy and CPON operating on the other side right here on the ONUs. So looking at that, talk a little bit about network slicing in here. You can read through that. Security, protection and resiliency. So again, go through a lot of these things. I won't cover that. That's pretty much it. And then it's everybody who's the different acknowledgments here. And you can see some of the folks that have been involved in this from, Broadcom, big chip maker, for example, Calix, a big fiber equipment manufacturer, makes the OLTs and the ONUs, ONTs. You got Charter, a big cable company, but also Charter and other cable companies very involved in fiber now, both from the fiber that's in their cable HFC network, as well as just doing fiber to the home in greenfield opportunities where they can. So you've got you got Cisco, router manufacturer, as well as other equipment. Cogeco, that's cable company. Comcast, obviously cable company. CommScope, equipment manufacturer. Cox Cable Company. Lots of folks in here. Liberty Global, big cable company. Mediacom, lots of cable. Rogers, got SET, obviously. Shaw, big cable company in Canada. Rogers also in Canada. I think did Rogers acquire Shaw or Shaw acquired Rogers? I think Rogers acquired Shaw. Could be the other way around. I can't remember. Sparklight, Bessemer makes equipment for fiber. Vodafone and CableLabs, again, listed there. Was it SET? Yeah, SET. SETE now. CableLabs is really under SET. They used to be two separate organizations, but CableLabs, I believe now, is under SCTE, but still doing its thing for these standards right here. So that's it. So a lot of information there. Again, what I did link in the down below in the description where you can get a look at that blog post, and there you can download the specification if you want to look at that more. And again, I did a broadcast on this with Marty Kukul back, I think it was I know we were in the office, so it was pre-pandemic. I was looking at the video. Pre-pandemic. So we did that video with Marty and I sitting at the same table there in a conference room where we talked about coherent optics. So check that out if you would like to. If this was helpful, if you would please give me a like on the video, I'd appreciate that. And if you're not subscribed to our channel, please subscribe. Click the subscribe button. Click the bell and you'll be notified when I'm live. And I'm live on lots of Tuesdays for Tech Tuesday at 3 o'clock specifically. But then during the week, I'm also live for broadband deployment news at various times during the day. So again, if you click that subscribe button and click the little bell to be notified, then you'll know when I'm live. You can watch it then or you can watch it later. Thanks for joining me, and I'll see you next time. Bye-bye.